Hello Year 10. Today we are going to be graphing polynomials, but before we start on the new work, let's quickly look at some cubics from last lesson. In question 1, we want to solve the equation 2x plus 3 in brackets all cubed is equal to 8. To solve the equation, we're going to do the cubed root of both sides. So the cubed root of 8 is 2. Then we're going to move the 3 across to the other side, which will give us -1, and then divide the 2 to get -1/2. In question 2, we want to sketch a cubic. So the -2 in the front of the x cubed will change the steepness of the cubic graph, but the -2 on the end will move the whole graph down 2 places. So that when you draw it, the point of inflection will be at -2. Then we want to find the x-intercept. So we're going to sub in when y is equal to 0. And we will get 0 equals -2x cubed minus 2. Move the -2x cubed term across to the other side, and it will become a positive 2x cubed equals -2. Dividing by 2, we'll get -1, and the cubed root of -1 is still -1. So my intercept is here at -1. My cubic graph will curve up through the -1 and then have a point of inflection and go down the other way. Okay, so that was our cubics from last lesson. Let's look at graphing polynomials now. To sketch cubic graphs in factored form with 3 different factors, we are going to find all 3 x-intercepts, and we'll use null factor to find out what those are. We will also need to find the y-intercept and then connect the points to sketch the curve going through. So just in a bit of a general form, if you have got a positive cubic, meaning that the number in front of the x cubed is positive, then your cubic graph will always start high on the right-hand side and finish low on the left-hand side, just like our basic cubic shape, which goes like that, high on the right, low on the left. Whereas if it's a negative cubic, it changes around so that it's high on the left and low on the right, which is what happens when we put a minus in front of our x cubed, that kind of shape. The numbers that are inside the brackets, so the -1 becomes a +1 here, the 2, they give you the intercepts on the x-axis. Let's have a look at our examples. Example number 1. Sketch the following graphs showing the x and the y intercepts. So the first question has been nicely factorized for us. So we just want to use null factor to find the zeros or the x-intercepts. From the first bracket, we would get x is equal to -3. From the second bracket, we would get x is equal to -1. And from the final bracket, x would be equal to 3. They are the x-intercepts. To find the y-intercept, we would sub in that x is equal to 0 into the equation. So that would be 0 plus 3, which is 3, times 0 plus 1, which is 1, times 0 minus 3, which is -3. So you're timesing the 3 numbers at the end of each of those brackets together, and that gives you -9 for your y-intercept. So to draw this, the scale is not particularly important. It's just a sketch, but you do need to make sure that you're showing and labeling your x and y intercepts. So I like to have a scale on my x-axis just because it helps space things out. It doesn't look too out of shape. So we'll have a -1, -2, -3, and 1, 2, 3 across there. So I have intercepts at -3, -1, and a +3. I also have a y-intercept at -9. So that's somewhere down here. I'm going to put it there. So see, not to scale, because it's definitely much smaller than the scale I was using on the x-axis, but that's okay. So this graph, the y-intercept helps me know which way my curve is going to go. So my graph is going to need to come down. And then when it's about halfway between the two dots, it's going to curve back up and it's going to go through that -9 to the -1. And then again, halfway between the next two dots, it's going to curve back down like that. And that's what the graph looks like. Let's try another one. Question B. That's again nicely factorized for us. So the first thing we're going to do is read off the zeros, which come from the brackets, but also if there's an x out the front, that also gives us a 0. So if we have a -2x or whatever that is at the front, -2x, -2x equals 0 will just give us x is equal to 0. That would be the first solution. The second bracket would be x is equal to 4, -4. And the final bracket would be x is equal to a +2. Then we want to find the y-intercept, which is when x is equal to 0. If x was equal to 0, -2 times 0 is 0. And then times 4 and times -2. But because that first number was a 0, it makes the whole thing equal to 0. Let's draw it. We have intercepts on the x-axis at 0, and then we need +2 and -4. So make sure you put dots or crosses at those values. The y-intercept is 0, so we can't really use that to help us find out which way the curve is going to go through. However, if we look back at our original equation, this minus that is in front of my whole polynomial is going to make my leading term a -2x cubed. So negative, the part that I'm after is the negative, which means instead of having the normal cubic shape, which is high on the right and low on the left, when it's negative, it's going to go the other direction. So my cubic is going to start high on the left-hand side. It's going to come down through the -4, halfway between, so about -2, it's going to curve back up. And then at about x equals 1, it's going to start curving back down like that. If you are unsure about which way your graph was going to go, you could sub in another value. So you could sub in that x is equal to 1, and hopefully it would tell you a nice positive number up here so that you would also know that way which way the curve is going. On the next page, question 2, it says find a cubic rule to represent the graph shown in factored form. So the x-intercepts, which is 0, 1, and 3, they would be the numbers that I would need to put into the brackets. So we're going to start with y equals, and the -3 would become an x plus 3 in the bracket. And the 1 would be x minus 1, and the 3 would be x minus 3. The trouble is we don't know how steep this graph has been made. So there could be some number here in front, which we'll call a, that we need to find out. To find out the value of a, which is the steepness of this cubic graph, we need to be able to sub in a point. And we can't use the x-intercepts, we need a different point. The other point we can use is our y-intercept. So I'm going to sub in the point 0.9 into that equation to find out the value of a. So y is 9, which is 0, a bracket 0 plus 3, and 0 minus 1, 0 minus 3. So it's 9 equals 3 times -1 times -3 is 9a. So it works out that a does actually equal 1, which means my graph has the equation x plus 3, x minus 1, and x minus 3, with just a 1 in front. You can't always assume that's a 1 in front though, so it is important to check to make sure that, to see if your steepness has been changed. Question 3, sketch the graph, and that's all it says, sketch this graph. This is not factorized, so I can't read off my zeros at all from this point. So I'm going to need to do all the steps that we were doing in our previous exercise to factorize up that cubic equation. And that's going to involve finding the factors. The factors of 15 would be plus or minus 1, plus or minus 3, plus or minus 5, or plus or minus 15. So I'm going to need to guess at least one factor, and I start subbing them in. So I'd start with P of 1, and you would sub 1 into that polynomial and see if you get 0. Unfortunately, you don't. It's equal to 16. You'd move on, you go to P of negative 1, sub that into your polynomial. This time it does equal 0, which means I have found myself a factor. X plus 1 is going to be a factor. So rather than keep guessing, I'm going to use long division to find the rest of my factors. So I'm going to use the x plus 1 that I've found, and I'm dividing the x cubed minus 7x squared plus 7x plus 15. And I'm going to divide. X cubed divided by x is x squared. X squared times x is x cubed. X squared times 1 is x squared. Subtracting, we get 7 minus 7 minus 1 is minus 8x squared. Bring the 7x down. Dividing, minus 8x squared divided by x is minus 8x. Timesing it out, minus 8x squared minus 8x. Subtracting, 7 minus minus, which makes a plus, will make 15x. Bring the 15 down. Dividing 15x by x, we get 15. Timesing it together, we get 15x plus 15, which means we have a 0 remainder, which is good. So my equation has x plus 1 as a factor, and the quadratic on the top will give me my other two solutions. I need to factorize that quadratic, so I'm looking for two numbers that times to give 15 and add to give minus 8, which would be minus 5 and minus 3. Okay, all that work, but now I have a fully factorized equation, which means that I can read off my zeros. From the brackets, using null factor, I would get x is equal to negative 1, positive 5, and positive 3. I would then also want to find my y-intercept, which I could sub in that x is equal to 0. But if you have the expanded version of your equation, the y-intercept is always the number on the end. So that means my y-intercept is at y is equal to 15. Let's graph this. So we need x equals minus 1, 3, and 5. So we need to label those x-intercepts. Our y-intercept is at positive 15, so my graph is going to come down through the 15, so that point there will be 15. Doesn't mean that that's the highest point. The highest point is always between the intercepts. Then it's going to bend down through the 3 and then back up through the 5, and that's what the graph looks like. Okay, so that's it for today. You can do exercise 10H.